Today we're going to be continuing equations and inequalities. Specifically in 1-3 we'll be talking about models and then applying equations to different situations like story problems. So our objectives are to use linear equations to solve problems and also solve a formula for a specific variable, which is the letter. So here's just kind of a general way how to set up a model. So a model is a mathematical representation of a real-world situation. So these will be the steps. So your step 1, you want to pick x or another letter if you want to represent one of the unknown quantities. Step 2 is represent the other unknown quantities in terms of x, which we'll see in a little bit. Step 3, write an equation in x that models those conditions. Step 4, solve the equation and answer the question. And step 5, you should always check your solution, especially in story problems. You'll be able to tell right away if your answer makes sense. Because if you get a negative amount for time, for example, or miles, you'll know you probably did something incorrectly. So let's look at one here. It says the median salary of a computer science major. So that's just, they took a lot of computer science major salaries and found the number that was in the middle of all those. It exceeds that of an education major by $21,000. And I have down here in long problems it's helpful to underline important information. So I'm going to underline 21,000. That's for a computer science major. The median salary of an economics major exceeds that of an education major by $14,000. Combined, their median starting salaries are $140,000. Determine the median starting salaries of the education major, computer science majors, and economic majors with bachelor's degrees. So your first step is you're going to use x or another letter of your choice to represent one of the unknown quantities. So since we are relating both our computer science and economic majors to the education major, we're going to let x represent that median starting salary for an education major. Step 2 is represent your other unknown quantities in terms of x. So it had said that the computer science made $21,000 more than the education major. So that'd be the education major plus $21,000 is a computer science major. Then for an economics major, they said it was $14,000 more than our education. Our education was X plus $14,000 is our economics major. And now we're going to use those to write an equation in step 3. So our education major, the starting median salary is our X. Computer science we said was X plus 21. And our economics major we said was X plus 14. And that all equals 140. And all of these are in terms of thousands, so we don't need to put the extra zeros behind. We'll just remember that in our label at the end. So now we're going to solve the equation. So we had x plus 21 was computer science, plus x plus 14 was economics major equals 140. So if we look here, we have 3 x's. We input our 21 and our 14 together to make 35, and that equals 140. Minus 35, that's 105 equals 3x. Divide by 3, so our x equals 35. So the starting salary of an education major, the x is 35, and that will be 1,000. I'll just put TH. The starting salary of a computer science major is x plus 21, so that would be 35 was our x, plus 21 equals 56,000. And then the economics major is x plus 14. So 35 plus 14 is 49,000. So we got 35,000, 56,000, and 49,000. Okay, so just to reiterate, it was $35,000 for the education major, $56,000 for computer science major, and $49,000 for the economics major. So now we're going to check that and make sure that those answers make sense. So the problem said that combined, the median salaries were $140,000. So now we determined in step 4 that we had $35,000 for our education major, $56,000 for our computer science major, and $49,000 for our economics major. And that does add up to $140,000, which does verify that we did our answer correctly. Okay, example 2. So this time we're choosing between two different rental cars. Car A costs $48 for the day, plus 8 cents for every mile you drive. Car B costs $52 for the day, plus 6 cents per mile. For how many miles will the cost for the two rental cars be the same? So for same, that's another word for equals. Now just a side note, you still need to pay for your own gas, so that's not going to be included. We're not going to worry about that right now. But you are paying the rental car company for the wear and tear the mileage puts on the car. So that's why there is a fee for the mileage, and then you will also be putting in your own gas at the gas pump. So step 1, you're going to let M represent the unknown miles. So again, you don't have to use X all the time. I used M for miles. We're going to represent the other unknown quantities in terms of that M. So if I look up here, car A is $48 for the day plus 8 cents per mile. So 8 cents per mile means 8 cents times every mile. So I'm going to say 0.08 plus our $48 daily fee. And then car B is $52 for the day plus 6 cents per mile. So 0.06 M plus $52 for the day. So those are going to be our two situations for this problem. And again, we want to know when they're going to be the same. So we're going to have to know when is plan A, or rental car A, I should have said, sorry, equals, I'll just put plan B. When are those going to be equal to each other? So as an equation, that would be 0.08 M plus 48. When is that going to equal our other rental car option? So now we're going to go ahead and solve this. Let me rewrite it. Now this one has letters on both sides, so I'm going to move my smaller letter so that hopefully I can avoid any negatives. So I'm going to move the 0.06 M to the other side. That'd be 0.02 M plus 48 equals 52. Now I can subtract the 48. That gives me 4 equals 0.02 M. Divide by 0.02. M equals 200 miles. So that means the cost of the two rental cars will be the same for 200 miles. So if you drove 200 miles with car A, you'll pay the same amount as driving 200 miles with car B. And again, we're not figuring in the gas pump and maybe one of them gets better gas mileage. We're just going based off the information they gave us. Okay, so these ones are really good to double check, pretty easy to double check also. So the problem asks for how many miles will they be the same. So we said 0.08 M plus 48. And we just said that 200 miles is going to be our magic number when they are the same. So if I go ahead and try that in my calculator, we're going to see how much that would cost. So 0.08 times 200 is 16 plus 48. That gives me $64 for car A. Car B was 0.6 per mile, 0.06 per mile, sorry, plus 52. So if I plug in 200 for my miles and add 52 to that, we hope that we get 64. If not, we're going to know right away we did something wrong. So that's 12 plus 52 is also $64. So at 200 miles, both the cars will be $64. So we know that we did our question correctly. Okay, now we're going to talk about discounts. So it says that after a 30% price reduction, you purchase a new computer for $840. What was the computer's price before the reduction? So we're going to let X represent one of the unknown quantities. So X is going to be the price before the reduction. So step 2, represent the other unknown quantities in terms of X. So we want to know what the price of the new computer is. So that's going to be 100% of our amount minus our 30% discount. So really, we're trying to find when it will be 70% of the original amount. And you're going to realize that when we're dealing with percents, we're going to want to write these in terms of a decimal. So if you think of a percent, 70% is out of 100. So 70 out of a possible 100. If you divide that, you get 0.70. So this is the same as 0.70x. So the price of the new computer is 70% of the original price. 70% of the price before the reduction. So we said write an equation in X that models the conditions. We could just say that 70% of X is going to be our price before the reduction. And something else that we were told is that after that 30% reduction, it costs $840. So once we're at 70%, we're at $840. So 70% of the original price, and now we're at $840. So let's go ahead and solve that. We had 0.70x equals 840. Divide both sides by the decimal. You're going to get x equals $1,200. So X represented the price before the reduction, so the price was $1,200 to start with. So now we're going to check it again to make sure it makes sense. So the price before the reduction, $1,200, minus the 30% reduction should equal the reduced price in the original problem. So there's two ways you could do this. You could say 1,200 minus 30% of 1,200 should be $840. So if I take 30% of 1,200, that's $360. So 1,200 minus 360 is $840. So that checks out. So that is one way to do it. Okay, so now I'm going to show you another way you could think of it. So 30% of 1,200, we just said 0.30 of 1,200 was $360. So the method we did before was 1,200 minus the 360 discount was $840. But we also said if you're subtracting off the discount, another way to think of it is we're taking 70% of the original price. You should get $840 that way. So if you did 0.70 times 1,200, you are going to get $840 as well. So the new price is 70% of the original. 0.70 times 1,200 is another way to get $840. So either way, it doesn't matter which way you check it, but this does verify that the computer's price before the reduction is $1,200. Problem 4. You inherited $5,000 with the stipulation that for the first year, the money had to be invested in two different funds, one paying 9% and one pays 11% annual interest. Annual means per year. How much did you invest at each rate if the total interest earned for the year was $487? So underline that part. The 5,000 is important. One's paying 9%, one's paying 11% interest. Okay, so we're just going to let x represent one of the unknown quantities. So we're going to let the x represent the amount invested at 9%, and we're going to, in step 2, represent the other unknown quantity in terms of x. So remember, we inherited $5,000. So if we take 5,000 minus the amount invested at 9%, which is our x, that is going to tell you how much is left over to invest at 11%. So for example, if you invested $2,000 at 9%, 5,000 minus 2,000 would be 3,000 left over that you put into the 11% investment. Step 3, write an equation x that models those conditions. So I'm going to explain where this equation comes from. So if you look at the 0.09x, that tells you how much was invested at the 9% rate. And then at the 11% rate, we said it was 5,000 minus that other amount, x. And we know that total, we make $487. Now if we distribute, that's where the 550 comes in and the negative 0.11x comes in. And then we are going to combine our like terms. We can put these together. Now they are on the same side of the equal sign. So you just put them together. 0.09x minus 0.11x is negative 0.02x. Bring down your plus 550 equals 487. Minus the 550 over. And that's where you get negative 63 on that side. Divide by negative 0.02. And that's where we get x equals 3,150. So our x represented the amount invested at 9%. We said that is $3,150. So that means the amount invested 11% is our original $5,000 minus the 3,150. That means there's 1,850 left that was invested at 11%. So you should invest 3,150 at the 9% rate and the remaining 1,850 at the 11% rate. And we'll go ahead and check that on the next slide, make sure it works out. Okay, so we said that interest earned at 9%, we're going to take 0.09 times 3,150, and that's $283.50. The interest earned at 11% is 0.11 times 1,850 is how much we put into that account, and that gives you $203.50. If we add those together, we should get the $487 that we needed for the total interest. So that one does check out, so we should have done it correctly. Okay, example 5. So this one's talking about perimeter. So the length of a rectangular basketball court is 44 feet more than the width. If the perimeter of the basketball court is 288 feet, what are its dimensions? Okay, so we're going to let W represent our width here. So W is going to be the width of the basketball court, so I'm going to put a W here and a W here. And now we need to make sure we only have one letter involved. We can't do W plus L because then we're going to have two letters involved, which isn't going to help us. So in step 2, we have to represent the other unknown quantity, which is the length. in terms of our W that we used. So we said that the length is 44 more than the width. So if you take the width plus 44, that equals the length. Now we can write an equation to x that models that. So our length is our W plus 44. So those are going to be both of our lengths of the rectangle. So if you remember perimeter, you take all the sides added together, and we said the perimeter is 288 feet. So we're going to take, we have a W plus a W plus 44 plus another W plus another W plus 44. So really we're taking all the sides and we're taking two of them, and it equals 288 feet. So I have 4 W's plus 88 equals 288. I'm running out of room. I'm going to finish this on the next slide. Go ahead and finish solving it out. So we had 4W plus 88 equals 288. So I can subtract 88. That's 200 equals 4W divided by 4. So the width should be 50 feet. So I'm going to put that number here. And we said the length of the basketball court was 44 more than that. So if I take 50 for W plus 44, that's going to give me 94 feet. So the dimensions of the basketball court are a 50 by 94. And we'll go ahead and check that on the next slide. So if I take 50 and 94 for my length and width, we're going to see if those work out. So you can see that I have 2 sets of 50 and 2 sets of 94. So that would be 100. And we have 2 times 94 is 188. That does equal 288 feet total. So that verifies that I did that question correctly. Okay, the next final thing we're going to be ending with is solving a formula for a specific variable. So another word for this is literal equations. So I actually have a supporting video just on literal equations that I found online that I think is very helpful. It gives many different examples. So we're just going to do 2 examples together, and then if you want more examples, you can go to that other video I post. So solving a formula for a variable means rewriting the formula so that the variable is isolated or alone on one side. And you're going to notice we're going to have more than one letter involved in these equations. We're pretty much rearranging equations. So for example, this one says solve the perimeter formula for W, also known as get the W isolated by itself, because we're trying to solve for the W. So here's the issue. I have a P, an L, and a W. And you're probably wondering, why would you ever want to solve for W? Well, if you knew the L and the P, and you were trying to solve for the width, you could just substitute in the L and the P to find the W right away. So I'm going to show you how to do that. So if we think of this as what we have to get isolated, we need that W by itself. So first we need to move this over to the other side somehow. But right now it's a positive 2L. So if I subtract that 2L, I'll do a cursive so it doesn't look like a 1. We're going to find that now the L's are gone on that side. But I can't do much over here besides write P minus 2L. And then on the other side I have a positive 2W left. The W is still not by itself, so I need to divide by 2, which means I need to divide this entire side by 2. So there's 2 ways you could write this. You could say P minus 2L divided by 2 equals W. The W is by itself, so we are done. So this would be nice if you already knew the P and you already knew the L, and you wanted to solve for W. That's why you would rearrange it. Another way you could think of this is both the P and the 2L are divided by 2. So you could write it as P divided by 2 minus 2L divided by 2 equals W. Then you could simplify. I can't do anything here, but I could divide these 2's and get just minus L equals W. So these two are the same. So I don't care which way you write it. This way, you could leave it like that if you would like to, but I did want to show you that you could divide that 2 out of one of the parts of the fractions. Okay, last example. Solve P equals C plus M times C for the C. Now here's the issue on this one, that C is stuck with both of these. But you could factor this C out, because really this is just saying 1C. So if I pull the C out, I'm left with 1. If I pull the C out of this part, I'm just left with M equals, the P is still on the other side. Now I'm trying to get the C by itself. So I would divide by 1 plus M, divide by 1 plus M on the other side. And that cancels that so that the C is all by itself now. And there's nothing you can do on this side, really. You could write that as two different fractions, but it's not really necessary. So again, this is a 1. When you have a lot of letters involved, it might be helpful to write the 1 very specifically. So that's another example of a literal equation. Again, I'm going to post another video that you can watch from something I found online. So please reach out if you do have any questions on these problems.